Hi, everybody. My name's Eric Multanen. I work with Intel, and I've been involved. I started playing around with OpenDaylight just to kind of pre-hydrogen time, and I've been working with OpenDaylight since then. We kind of got our team formed and started contributing in the lithium time frame. So we've been participating in that, in OpenDaylight since then in a number of different areas. I think if you've been here this week, you've seen other talks from other folks at Intel on what we've been doing there. So my talk today is quality of service enablement in OpenDaylight, and on my first slide, I'll kind of narrow the scope of what that actually means. A little bit about myself too. Previous to working on OpenDaylight, I spent a number of years working on data center bridging for Ethernet NICs and enabling that in some of our NICs, and that's kind of an Ethernet layer quality of service related technology. So I have some interest in quality of service. All right. So quality of service, what are some of the things that come to mind? I'm not going to go super deep in quality of service. I've seen a lot of presentations and use cases this week on different things that people are doing where they require quality of service, but a few key things that come to my mind are classification. So, the reason we need quality of service is there's all kinds of different traffic: voice, video, real-time streaming. There's automotive use cases. You got file transfers. So, for a lot of different reasons, traffic needs to be classified and handled differently. So. And that's where network controller comes into play, is how to manage that sort of across your network in a consistent manner. Policies, how are quality of service policies defined? What are some of the parameters? So things like bandwidths. What are bandwidth limits? What's the maximum bandwidth, or maybe what's a guaranteed bandwidth that you want to give a certain type of traffic. Latency parameters, is the traffic sensitive to latency or not? Jitter, drops, can you drop some packets from this flow, that kind of thing. And then some of the mechanisms. So policing, again, you prevent traffic from, prevent a flow from using more than its allowed amount of bandwidth, for example, or shaping. You just want to spread out the traffic and keep it smoothly flowing and not come in bursty lumps, that kind of thing. Marking, so maybe across the network you want to have certain types of quality of service, those packets marked so they can be handled consistently as those packets traverse through switches and routers and so forth. And maybe things like congestion control play into this. So I'm not going to be talking about all of these things in detail. What I really want to talk about specifically is a couple of the new capabilities that are in the Boron release, and specifically, I'll start out talking about the OVSDB plugin and some of the enablement that has been done in that plugin to allow configuration and use of the QoS and Queue features of that, as well as the interface policing. If you've been around OpenDaylight for a while, you know that there's the MD-SAL, which is kind of the core of the controller, and there was at one point originally the AD-SAL as well. So the OVSDB plugin was originally written based on the AD-SAL in the hydrogen and helium releases, and that mechanism at that time allowed full configuration of the OVSDB tables. But when in lithium, when OVSDB switched over to the MD-SAL, the OVSDB schemas had to be modeled in the MD-SAL, and not everything in the OVSDB schema was put into the MD-SAL model. So actually in Beryllium was the initial introduction of some of the QoS and Queue features in the MD-SAL schema, and then what I'll talk about today is how it looks now in Boron. And there was a few. There was a few improvements that were made, and then also a few additions. So I'll cover that a little bit. And then the Netvirt application is at least one use case where some of the QoS features are being used kind of in a top-to-bottom case, and so I'll talk a little bit about that. And that's really what I want to talk about today, is the scope. So a couple slides here on quick overview of some of the Open vSwitch QoS capabilities. And so part of Open vSwitch, as you may know, is the OpenFlow protocol itself. OpenFlow plugin already is present. I don't think there's anything necessarily new in Boron related to QoS, but it ties into some of the topics later. So for example, traffic classification. You write OpenFlow rules, classify traffic, and you can set DSCP values, for example, to mark that traffic. There's other capabilities too. You can do the VLAN priority code point and some other things. I just point out specifically the DSCP because it'll tie in a little bit when I talk about Netvirt. And then another thing that'll be related to the QoS feature, the QoS tables, is in OpenFlow you can set a queue as part of the output action. Send this flow to this particular queue, and then I'll cover this here on the next slide. So in the OVSDB side, or portion of OVS, there are two tables, QoS and Queue. And so let me spend a few minutes here and talk about what's going on here. So QoS, the QoS entry, the QoS rows, and the QoS table define kind of the top level QoS mechanism. So in the Linux OVS, you have, well, I guess you could say the QoS have types, and there's several types that are available. Linux supports the Linux HTB. It's a hierarchy token bucket. And then there's HFSC, which is something like hierarchical fair scheduling curve or something. And these are kind of shapers. You can do some fairly complex things. I'm not going to talk about how those work. I have a link or two that you can dig into that if you want to on your own. But common with these two queue types is in part of the other config field or column in the OVSDB database is a max rate. So you can define the maximum rate of bandwidth that those QoS entries support. I also want to point out in OVS 2.6, the OVS with DPDK variant of OVS, that's the user space component, user space data path of OVS that uses the DPDK for enhancements. They got an egress policer QoS type included in the package. So the egress policer is not a shaper, it's a policer. So you define kind of a committed information rate and a burst amount, and then basically when the traffic exceeds those values, the traffic is just dropped. So it's a policer, but it's configured here as a QoS entry. So in addition to the type and a rate information, a QoS entry can take a list of queues. So and the queues will be second, but basically at the QoS entry level, you have a list of queues. It's a map of integer and queue reference. So the queue numbers would be like 0, 1, 2, 3, 4, whatever. It's up to a fairly large number. And then the associated queue entry. And so the way this works then is you can write OpenFlow rules, and as part of, so the traffic that matches that rule can then be said, the output is send it to this queue number. And that way you can get the quality of service that's defined for that specific queue, which is defined here in the next table, which is the queue table. And in the queue table, is where the attributes of specific queues in OVSDB are defined. Included are that it's basically a DSCP value. And then the other config column is where you define things like minimum rate, maximum rate. I think both Linux HTB and HFFC support both of those. And then some of these entries, some of these queue types will support additional parameters that are also configured via the other config column. So take a look at the OVS documentation for specific details on how you configure these things. And then the other thing, if I didn't mention it, is the egress policer QoS type, which is the DPDK QoS policy, doesn't take any queues. It just applies to the port itself. And the other thing too I wanted to mention is these QoS the QoS policies defined here are in effect for the traffic egressing the vSwitch. So traffic going out of a port is what these parameters apply to. All right, I think that's it. Oh, and then, okay, so then the other thing is for OVS and OVSDB configuration of QoS parameters is the interface table. So an interface, so OVS has bridges, ports, interfaces, and some other QoS and Queue tables, like I mentioned. The ports have interfaces associated with them, often one-to-one, but perhaps more than one if you're doing, linking aggregation, things like that. So anyway, the interface table has a couple attributes, simple policing attributes. There's a policing rate, which is basically the maximum rate at which you start dropping packets, and then you can also define a policing burst rate. And it'll go a little flexibility there for if you exceed it just a little bit. And the other key thing to point out here is the OVS with DPDK version of OVS introduced support for these attributes in the OVS 2.6 release. So that's pretty much what is available as far as QoS goes in OVSDB. And here's a few references to dig into. So the Open vSwitch schema table here in the first link is a pretty good place to find out some of the details of some of those QoS entries and what the other config values can be and that sort of thing. The second link is on the Intel site, and it talks a little bit about how to configure and use the OVS with DPDK, egress policer, QoS type. And then I put at least one link there on some of the Linux shaper entries. So take a look at those if you're interested. All right, so how did this come across? Okay, good. So on this slide, what I want to do is talk a little bit about how the OVSDB QoS and Queue tables are modeled in the OpenDaylight MDSal. So 3 basic components. I'll actually kind of go right to left. So, and a little bit of background history. So the OVSDB there's an OVSDB Yang model, and it's used to model the OVSDB tables in the MDSal. These are augmentations of the topology model. So OVSDB nodes are one variant of augmentation of the topology node model. And that OVSDB node model is basically representative of the open vSwitch table in the OVSDB schema. And it sort of represents effectively the host. So it's like the connection parameters and some of the top-level host level attributes of that OVSDB host. QoS and Queue tables are, if you get into the details of the OVSDB schema, they're root tables, which means they live somewhat independently. They can live independently of what they're connected to, which is the port. So you can create a QoS and Queue entries and then kind of link them up after the fact. Or if you assign a QoS to a port, if you delete the port, the QoS entries remain in the table. So they're somewhat independent. So basically in the OpenDaylight model, in the OVSDB model, the QoS and the queues are basically just maintained as lists in the OVSDB node model. And so that's what I'm showing here. And then the queue, and so the way it works is you can define your list of queues. And what I'm showing here, by the way, is just snippets of the MDSal configuration. So this might be the kind of thing you would submit via RESTconf for configuring these entries, and then that's in the config side of the tree. The operational side, you'll see additional information like the OVSDB UUIDs and all that. That information will show up if you look at the operational side when it's active. So you define your queues, put them in the list, and then you can associate them to you can add those queues, refer to them in a list that's maintained in the QoS model, which is also a list in the OVSDB node. And then the termination point is an augmentation of the topology model's termination point, and it's associated with OVSDB bridge model, which are also, the bridge is also an augmentation of the node model. So basically, in the termination points for OVSDB bridges in the MDCell model, there will be a reference to the, you can add QoS entries, and it's basically a reference to the OVSDB node. You'll note that it looks like a list here, and actually the OVSDB port only takes one QoS entry, but from the modeling perspective of MDCell, it's convenient to have the QoS entry as a list entry, because then you can kind of drill in and manipulate the QoS entry drill actor. You can add it, delete it, without having to mess around with the other attributes of the port. So this key is just a kind of a static one. There's only one key, one. So when you add a QoS to a port, you just say key one and put it in, and that's how you can delete it. So let's see. A couple other things I just wanted to point out. So in the MDCell, the key for the QoS and Queue entries is an ID field. It's not in the OVSDB schema on the OVSDB host, it's the UUID value, which is how these things are identified on the host. And again, I don't show the UUID here because this is the config side, but you will see it if you see the operational side of the data. And then the other key point, or one of the other key points I wanted to point out, is the references to, like I talked about here in the queue model, the QoS model, the list of queues is just an instance identifier pointing to the queues. And the same instance identifier of the QoS is how the termination point or the port links to the QoS entry. The reason I call that out is in the Beryllium release, these linkages were actually done using the UUID value. And so that made things a little bit awkward in terms of configuring this stuff, because in order to define a queue entry and assign it to the QoS list, you first had to create the queue entry and have it actually become operationally active, and then look in the operational data store, get the UUID, and add it to the list in the QoS. And the same token with the termination point. In the Beryllium model, the QoS entry in the model was actually the UUID of the QoS entry, and that turned out to be a little bit awkward and inconvenient. So this is the way it's done now. And so actually, if you look into this in detail, you'll see that those UUID values are in there. They're marked as deprecated, so in Carbon we'll want to take that out and just use this method. But if you get into it deep, you'll see that. Let's see. The other key point is most of the attributes of the queues and the QoS entries are done by the other config column in the OVSDB table. All of this stuff should be fully configurable via the MDCell models, so that makes it pretty handy. And finally, in the OVSDB repository, there's a Postman collection that has some samples of RESTconf calls that can manipulate this stuff. So take a look at that and try it out. All right, so okay, call to action. So yeah, try it out. Develop some QoS applications. So here's a basic model. You got OpenDaylight, the OVSDB models there. You can write ODL applications that talk to it via the internal MDCell API, or you can actually have external applications talking via RESTconf and manipulate these models. In Carbon, like I was just talking about, remove some of the deprecated elements of the model, make it a little bit cleaner, and there was some documentation written for Beryllium. I need to update it for Boron to describe the new stuff. And then we have some of the CSIT testing to just be part of it. There's some of that testing is in the works. We want to get that pushed upstream and just get this kind of fully supported in the plugin. All right, so let's see. Timing-wise, doing pretty well. So there we go. So speaking of applications, I want to talk a little bit about an actual application that is in Boron that uses some of this. So this is showing here on the right side, we have OpenStack, and OpenStack has, of course, here at OpenDaylight, the Neutron API. Part of the Neutron API is a quality of service extension API, and that API defines QoS policies, which can be associated with Neutron ports or Neutron networks. And those QoS policies then can take one or more rules. And at the time we started working on this, there was rate limiting rules and DHCP, or I think it should be DSCP, sorry, DSCP marking rules. And I say not yet because we don't have it implemented in Netvirt yet, but it is part of the Neutron API. And so anyway, Neutron has a QoS API, and what we've done, some of my colleagues at Intel have added to the networking-odl driver a QoS notification driver. So basically you can configure networking-odl to support and use this notification driver to support the QoS API. And then on the OpenDaylight side, we did a number of things. So we added into the Neutron Northbound models the Yang models to represent these QoS, represent the QoS API. And Pramod sitting right there was actually one of the key developers working on that. And so basically, QoS API from Neutron can come in and it gets captured in the Neutron models. And then Netvirt is an application that is basically a Neutron provider. And so what we did is, or what was done at least for Boron, is added to Netvirt, listen to the QoS model changes in the northbound, and then make appropriate changes to those associated ports or networks on the southbound using the OVSDB model via the OVSDB plugin. So right now in Netvirt and at least in Boron initial release, we have rate limiting support. The rate limiting actually uses the ingress policer feature. So it's really just configuring the policing attributes of the interface table. I marked, QoS, I got the egress and ingress here kind of asterisks or highlighted just to be cautious. Ingress, egress is totally dependent on your perspective. So from the Neutron perspective, egress refers to the virtual machine. So egress is respect to the virtual machine, whereas from the vSwitch perspective, ingress, egress refers to the vSwitch. So polarity is kind of reversed, so you got to be a little bit careful when you're looking at these things. I said DHCP marking not yet, so that's why I kind of show the OpenFlow plugin a little bit faded there in the diagram. We'll probably use the DHCP marking features of the OpenFlow to implement that capability. If you're aware of Netvirt and Boron, there's been a lot of changes in Netvirt and Boron. It's kind of basically a whole new code base, kind of the mashup of the VPN servers code and the old Netvirt code. And so it's kind of a new architecture, and we'll need to figure out how this QoS API and support needs to be built into that. So finally, what's next with Netvirt and the applications? Again, give it a try, see how it works. And I keep saying DHCP on here instead of DSCP. But yeah, we want to add the DSCP marking rules. Additionally, the Neutron QoS API is not static. There's new stuff coming there. There's egress bandwidth support, so that includes both the rate limits as well as minimum bandwidth guarantees that are being added to that. And then I just learned yesterday that I knew that the UniManager, another ODL project in the Beryllium release, had done some proof of concept using the QoS, OVSDB QoS entries I mentioned coming into Beryllium. But maybe UniManager also uses the Netvirt as a kind of a southbound, I guess you could say. And so as part of all this work, we may want to look at making sure that the QoS capabilities of Netvirt aren't super tied to just Neutron, but kind of provide a more generic QoS API by Netvirt that can be used by Neutron or by other applications like UniManager that might also be trying to use the Netvirt as a base. So that's what I have. Any questions? If not, I think we're on time, and you're next, right? Thanks.